Hi everyone, we're going to tell you about our mobile app Blurble, an online platform for hosting book clubs. Blurble allows book clubs meeting in the real world to continue conversations online as they read, as well as empowering readers to start completely virtual clubs for the books they love. Many online platforms have been adapting to the needs of users in the new normal post-COVID-19, and those needs partly inspired this app. Reading has become a hobby for many people during lockdowns, and it doesn't have to be a solitary pursuit. That's where Blurble comes in. Before I start the demo, I'm going to introduce the team. We made the decision early on to split into a back-end and a front-end team, with James and Sam on the back-end, and George, Joe and myself tackling front-end, and we collaborated closely every day. I'll take us briefly through the journey of a new user and then hand you over to George to demonstrate some more features. So this is the sign-up page. The notable features here are the date of birth. This isn't actually stored on backend, but is used to enable or disable access to book clubs which choose to be age restricted, which means we can have a really good user experience for users of all ages. Location is also stored quite generally, just city specific, and Sam is going to show us how this works in the app shortly. Once signing up, a new user can go to their profile page. At the bottom of the profile page, we can see our blurbles. These are a point system that we use for incentivizing positive interactions on the app. Once they've been to their profile page, a user can go to their homepage, which is where they'll see all the clubs that they're a part of. By default, all users who sign up are part of the global Blurble book club, as we can see here. I'll now hand you over to George to take us through the journey of an established user.
Now if the user clicks on the magnifying glass icon, it'll take them to the book club's search functionality. Within here, users can input an author or a title, and Google Books API will return them the most relevant results. They can tap on the book that they were looking for, it will give them more information about it, and if they want to nominate that to be the club's next book, they click nominate, submit. Now if we navigate back to the club, into the vote section, you'll see the book that they submitted is now there, and people can vote on it. Each user can vote on any book once, but they can only vote once per book.
Upon re-navigating to our user's profile page, they can then redeem their blurbles by clicking on the Blurbles button. Now, navigating to our Browse Clubs page, we can see every book club in which our user is not currently part of. When scrolling through this page, if our user sees any book club in which they may be interested in, they can click on the More Info button, which will then take them to the club's page. If our user is still then interested in joining, they can do so by clicking on the Join Club button. Here, our user can see a club's discussion page and filter other users' comments with our page slider. This was an integral part of the page, as it meant our users could not accidentally see comments on the current book related to a page our user has not yet got to. If our user wants to post their own comments on the book, they can do so by clicking on the comment icon. On this post comment page, our user has a texting button which they can input their comment and a page slider to set a reference point to a page in the current book. After posting a comment, they can reload their club's page by swiping up to force a refresh, and upon navigating back to the discussion page, they can then view their comment with the page slider. I will now pass on to James to talk about selecting the next book.
Once all members have finished reading and discussing the current book, we can then confirm the next book choice. This button will set the current book to the winner of the vote, reset all current book nominations, archive the previous book, and reset the user's ability to vote. We debated the idea of this happening automatically on a certain date, but decided users would want more flexibility to end the vote once they're ready to move on. Now Sam's going to talk us through our library API implementation.
On each club page, there is the compass icon. It was important to us that Blurble had an option for acquiring the book selected, but also important there'd be no financial obstacle to engaging with our app or the joy of reading. As such, clicking this compass icon interacts with an API called Libraries Hacked, which in turn searches libraries to provide stock information in the user's location. We hope for a further integration of this feature in future development. This concludes our demo. Our first decision when establishing the backend tech stack was about the database. During our research, we had to decide between relational and non-relational databases. Non-relational seemed like the better choice for our purposes, so that we could nest data and cross-reference documents without needing to join tables or specify our data's relationships. When researching, we found a common solution was MongoDB, working with the package Mongoose. This had the added benefit of serving back our data in JSON docs, allowing for easier manipulation of the data and fewer util functions to validate before seeding. MongoDB had a significant learning curve, but it gave us an opportunity to learn something new and adapt to a new way of storing data. Using MongoDB presented some challenges around trying to build migration tables and learning additional packages such as Migate-Mongo, which would enable this. Having this functionality allows for future scalability of the app.
For our API, we used Express to enable us to create a fully formatted MVC application. We decided to use Jest and Supertest to ensure our functionality was fully tested from end to end and would enable us to expand functionality with confidence that our tests were well written. When testing, we also realized that we needed to be careful around seeding and connecting to our database, and with the syntax required for promise chaining and callback functions, we had to establish how these worked before we could write any tests. Finally, we made the decision to host the API in Heroku because of its wide use and effectiveness. We initially also planned to host the database on Heroku, but after a not insignificant amount of time, we realized that the MLabs extension, which would interact with MongoDB, was discontinued. As such, after some research, we decided to host the database separately on MongoDB Atlas, which presented a number of challenges we had to overcome around seeding the data properly.
When it came to the front-end tech stack, we decided to use React Native as our main tech on the front end, as it allowed us to create our app for both iOS and Android while still using JavaScript rather than the traditional Swift for iOS and Java/Kotlin for Android. We used React navigation with our app as it allowed us to navigate with tab icons across the bottom of our app screen, which was the main thing in our design. There was an initial learning curve to React Native and navigation. However, persistence was key to success. We initially had a 2-day spiking process with Ionic, but decided the learning curve was too steep and ultimately time consuming, especially with the time we had allocated. I will now pass on to Joe to talk about other tech.
In addition to the packages Joe mentioned, React Native Elements was also used, as it's nice and intuitive and provides good-looking cross-platform elements for both iOS and Android devices. There was a slight learning curve to using React Native over React, which we're used to. However, it was not too hard and we were able to pick it up in a couple of days. Also, we employed a forward-facing coding structure to this app, and as there was only functional components used and React hooks, which were new to us. However, once we got the hang of them, it made it much faster, navigating states much easier. Expo framework was used to develop the app, which allowed us to quickly iterate versions and see changes update on a simulated iOS device, which was nice when sharing screens and working on Zoom. We could see our work in front of us as we did it. Now I'm going to hand off to Nick, who's going to walk through the APIs used in the project.
Yep, we access public APIs on front end to allow for a seamless user experience. For searching for books and providing information about them, we chose the Google Books API, which came out on top of other alternatives because of Google's powerful search logic. The Libraries Hacked API was also the obvious choice for finding libraries near to the user's location, and this one was a great bonus for the app. That's everything from us. Thanks very much for watching, and we hope you'll be earning your Blurbles soon.